Okay, welcome to another business data analytics, and this is a class of CPL Senaka, and here we cover business data analytics. So today I want us to cover something on management accounting, isn't it? So we'll do something on regression analysis. Isn't it? Today we'll be doing something on regression analysis. Just a minute as I set up my things here. So just a minute as I set up my things here. Okay, we're waiting for someone to join in. Okay, let me share the screen. Right, as I was saying that today we'll be talking about regression analysis, and I'm not seeing anyone who is in. Okay, we'll wait. And just like to say that this is a BDA online tutor, and we have various packages, isn't it? Okay, yes, we have the starter packages. We have the theoretical notes and limited access to class online. And also the premium package where we give you the theoretical notes, the full class, and we give you some of the recorded class videos. And for the light package where there is a private consultation where you can consult, and I get to, you see, you come, you experience how data analytics is done under Microsoft Excel. And just to emphasize that we are waiting for someone to join in. Yes, if someone doesn't join in, I don't know, my student today is very late. And so regression analysis, and just for an emphasis is that this question was in the last examination. Okay, this question was in the last examination, in the December 2022 examination. And I'll just do this control board so that I can see clearly. And all right, so just a minute. We are waiting for students to, at least the number to grow so that I will start. Okay, I see that someone is in, so we shall just start directly. Okay, so under regression analysis, there are two things actually you need to know. That is the formula. In fact, this is, as you can see, this is a linear. It's a linear. There are two, so you need to know that there's a linear equation. I'll write here y equals to a plus bx. Isn't it? You must know this equation, and I've said that you must have a background knowledge regarding management accounting or QA to solve this one. So, and you must know that we have the dependent and the independent variable. So the dependent variable actually depends on the dependent variable. So for our case, you can see that our production cost actually depends on our quantity of units. So our quantity of units is independent, and our production cost is the dependent. So let me write because x. So our x will be independent, and our y will be the dependent because it depends on x. So there are these two. So for here, our y will be our production cost, and our x will be the quantity produced, isn't it? I must know that before we start and this equation. So when you come to the required, you've been told that determine the variable cost per unit and the total variable cost used in regression analysis. So here we must go to data. Then we go to data analysis. Here under data analysis, you can see there are very many things. We have if you want to find the correlation covariance, the descriptive statistics, that is the mean mode, and what you have the exponential smoothing, F test for two sample variance, this is the significant test, we shall see that. And also we have even for auditing the sampling you can also take it from there, the moving average analysis. There are so many, but here we'll be looking for regression. So our regression is here. Come to take regression, click OK. So it will bring you to a new window here that will be requiring you to fill in. And so they are requiring you, let me move it at least here so that I see here. Okay, the input y, the y, and we have said our y will be our dependent. So our y will be our production cost. We take from here up to there, isn't it? Then our x is here. Right, and our table doesn't have the labels, and also the constant zero is not there, but you can see on part somewhere I've been asked about the 95% confidence level. So we will take this one. And this confidence level is always likely to be 95% or 99%. So actually that is, let me say, like 5% of being wrong. Actually, if you've done, let me say, like statistics or something like that, you know the story of the null hypothesis. So this one will be like a 5% chance of being wrong, and the other 95% of being right, isn't it? So we'll come here, we'll just check under this sheet. So we'll select output range, and so under this output range, we want to put it here. Let's say here, isn't it? We go back. So it's not the residuals. You should make sure you tick these ones, this one, and also you tick the line fit plot. So this one is to, it will bring like it will already have been plotted, isn't it? So we click on OK, and here we get our summary output. So here is where we are saying that if you don't have a background knowledge regarding management accounting, actually you can't. Let me spread this one out, and you see Fuck, sorry. My mic was muted. I don't know what happened, but I see we are back. And like what I was saying, that the multiple R, this one is the correlation coefficient. And the correlation coefficient is used to measure the strength of the relationship of the linear relationship between the two variables, that is the production cost and the quantity. And I've just said that regression analysis, actually, these are measures of the goodness of the fit, isn't it? Actually, this one, it's like, maybe I take you through. And I've said that adjusted R is the variance rate divide adjusted with the number of predictors, isn't it? And I've come to say that the standard error, this standard error here, the standard error, this one is like the standard deviation. Actually, like, here we have taken a group, and so from that group we are want to estimate the future. So that group is just a sample, it's not like everything. So that's why we have the observations are 12. You can count their observations there, there are 12. And so I'm saying the standard error is like the standard deviation, isn't it? But you can confuse with why standard error. It's just another name so that you can't confuse it with the population standard deviation. So we say standard error. And so we come to ANOVA. So under ANOVA here, we've been given the regression. And the first thing here is the DF. So the DF is the degrees of freedom. And the degrees of freedom actually measures, because I've said that like regression analysis is just the measures of goodness of fit. So like the degrees of freedom, like in other words, let me see how I can, like it measures the number of independent variables that can vary without breaking the constraint. I mean, you see, it measures how many independent variables. You say the dependent variables are our quantities, isn't it? Can vary without breaking any constraints, isn't it? And then the sum of squares, the SS, this is estimate the overall variation, not population. It estimates the overall variation from of the data. Actually, it estimates the overall variation of the data from its mean, from the mean, isn't it, from the mean of the data. Actually, I know if you have not done management accounting on QA or statistics, this one can be very challenging. So we have the MS, this one is the mean of square. So this one is the average variation of the data, isn't it? And the F, so the F is the F value of the distribution, the value of the distribution. Like this one, let me say like this one is used to measure if the model, so this regression model, it's statistically significant, isn't it? It measures if the model is statistically significant. And so we come to significance F. This one also measures whether the model provides a better fit for the data than the model with no predictors. This one, the significance, like whether the data model provides a better fit for the data than the model itself, isn't it? So, and so here we come to our coefficients. So we have intercept and the x variable. And so for our equation, I've said the equation was y equals a plus, plus bx, isn't it? So here, this is our equation, isn't it? So this coefficients here, this one are the like are our values, are our a and b, isn't it? So this x variable, this one is the variable one, this one is the b in the equation, and the intercept, this one here, this one is the a in the equation. So from here we can estimate y, isn't it? So, and like you know that let me do this y. equals to the total cost. A equals to the fixed cost. B equals to the variable cost, and X equals to the number of units, isn't it? So you must know this one here, how it goes. So this one is the total cost, isn't it? The Y. So here, this one is our B here, and our A is this one here. And I say the standard error. The standard error is like, let me say, the standard deviation, but for these variables, not for the whole statistics, isn't it? So, and we come to the t-stat. Actually, so this t-stat is actually used when the number of, let me say, the samples here, the number of observations are less than 30. Are less than 30. We use the t-stat. It's also on Excel. And so, but just some, this is what you know. If 30 and below, we use the t-stat. If it's above 30, we use the z-stat. And that one it's used in computing the confidence interval. And that one, I say that we shall look at two examples of the confidence level, isn't it? We shall look how you use a t-stat and how you use a z-stat. We also have a z-stat, and I'll say that the difference is in the number of size of observations, because they say that if the observations are below 30, like there's something called the central limit theorem. So like when the number of observation grows, what is it called? The mean of the population, the mean of the point estimate comes closer to the mean of the population. Like, so it makes the population be like it's normally distributed, isn't it? And so, and the p value here, So, and like this t-stat, like, let me say it's like null hypothesis versus